So if we look at this Egyptian meatloaf, now why do you think this is called Egyptian meatloaf? Shaped like a pyramid. Why does that relate to the Egyptians?
Because they made the pyramid.
Because the Egyptians made the pyramids.
No, they made giant pyramids.
Well, okay. So there's an argument that aliens made the pyramid. I argue that aliens could have helped the Egyptians make the pyramid. But there's a lot of evidence that the Egyptians were involved, so I don't think we can say that it was just up to the aliens in the drawer.
I don't think aliens.
Actually, no, aliens did.
So, could the waiters, the question that's posed to us here is, could the waiter's slice be even? Like if I cut the top off, give it to Bella, and give the bottom to Cassidy, are their portions equal, or is there an easier way to make sure that they would have equal portions? So we've got a pyramid that we're trying to cut. Katie? Now, what do you mean cut it in half? Because that could be cut in half. What is it? Vertically. So what you're saying is make a vertical cut. So if I try to draw this with perspective, so I'd cut through what point? Because I can move this. Where would I need to cut through?
It's like on the top of this, like of the triangle thing.
What was it, Isaiah? The vertex. I need to cut through the vertex, so my cut would come straight down here. Again, I apologize for the glitch in my smartboard. It would come straight back the back and straight across the bottom. So that would guarantee me equal slices. But if we go back to the original question, could this horizontal slice create two equal portions of meatloaf? Could we figure out a point where the volume of those two pieces would be equal? Thomas?
If there were like numbers, like if there were units on the thing, then we could find out if that was.
So I'm not looking for all the details. I agree with you. All I really want to know is, could it be equal?
Well, we'd have to, like, the only way we could find out if it's equal is if we had the volume,
But could it be? Could I cut this in a specific place so that the top would equal the bottom? Yes, right? I could. It's possible. Guys, I could cut any shape into equal halves. It's just really, really difficult by using the horizontal slice. So everything that Thomas was saying, well, we would need to know the volume, or we would need to know the dimensions, or we would need to know. By needing to know, it makes it more complicated. If we know this is a square-based pyramid, and I cut straight through the vertex down the middle, and I cut it in half, left side, right side, it will be two equal halves. So it's all about what cuts make sense in a given certain situation. So now we're taking what we talked about yesterday, our slices of prisms, and now applying it to slices of pyramids. So we've got two options when we slice a pyramid. Now when I think about the horizontal slice, what's going to be different about this horizontal slice situation compared to the prism horizontal slice situation? Bella? Okay, the bottom faces a rectangle, but I could have had a rectangular prism yesterday. Like if we had a rectangle and then it had some height, and then another rectangle. So we could have a rectangular prism, and then yesterday we looked at how we could make a cut through the prism. I'm trying to make it straighter, but it's not very good. If I break my own rules from yesterday, it's easier to draw if I make my lines solid, and then I could always go back and erase. So I can have that horizontal slice. Anywhere I move this slice, what do we know in the prism about anywhere that I move that horizontal slice? It's gonna be the same size as the bottom face. Now let's think about if I make a horizontal slice in my pyramid. What about if I shift my horizontal slice in my pyramid?
That's not gonna work.
What do you mean it's not going to work, Oriana?
Has to get smaller. I don't know, but no comment.
Well, the comment that you already made was correct. Eli?
When you move it up, the shape gets smaller. Like inside.
So as I shift my horizontal slice closer to the vertex, it gets smaller. As I shift it closer to the base, it gets bigger. So we have many different sizes here. So I would, on your notes, highlight, underline, circle, star, something for the different sizes. And that is all going to depend on the location of the slice. That's all going to depend on the location of the slice. So now what about the vertical slices? This gets real tricky. I know you have it on your paper. Thomas?
It's a square pyramid. If you cut it straight down like this and cut it straight down like this, it'll be the same. But if it's like a rectangular, if it's a rectangular pyramid like the one on the notes,
Yeah, highlight rectangular.
It's gonna be different.
Exactly. Now both of the slices that you just referenced, Thomas, cut through the vertex. Does my vertical slice have to cut through the vertex?
No, it doesn't though.
It doesn't have to. So think for a moment, we're going to look at a problem with this, so I'm not going to give it away to you right now. Think for a moment, what would my vertical slice look like if it wasn't through the vertex? Try to draw a picture of that. Don't make it too big or anything, but off to the side here, try to draw a picture of what you think it would look like if it wasn't through the vertex, if it was off to one side.
I don't get it. Like, what is to the other?
So if I sliced my pyramid here, instead of slicing at the vertex, if I shift it off to the side. So think about, I only put these away because I'm worried about the people that are in the building at night. Excuse me, gentlemen. Think about if we have our pyramid and we slice through like here versus if I slice through the vertex. So through the vertex, I'm going to get a triangle because I start at the point, I come down the sides, and I get to the base. But through here, I don't start at a point. I start right across this section. It's narrow up here, but as I get to the bottom, it gets bigger. So we're going to look at what shape we would get, but just have that kind of in mind as we move forward. So, our two slices, the first and third, are through the vertex. So I want you to draw what two-dimensional shape will we get and label any dimensions that you know for certain. Only label what you know for certain. So I've got the same pyramid, rectangular pyramid, same pyramid for all three of these. Draw what shapes we're going to get. Take a second. I'll give you guys a minute or so. I do not have a rectangular pyramid. That's the only one I don't really have. I've got square. I've got cylindrical. I've got triangle. Got like every other kind. Alright, time to bust out the cards again. So Zach, you can choose first, second, or third shape. Yeah, always. Franny?
First.
What kind of shape do we get there?
Triangle.
A triangle, because I cut through the vertex down to the bottom. So if I cheat on here, I get this shape. What dimension, or do we know a dimension that goes with this?
3 for the bottom.
Yeah, because this edge right here is going to be the same as that edge right there, and that's 3 inches, so we know that the front of that, or the base, would be 3 inches. Eminal, can you help me out with any of the 2 that are left? Oriana? Katie? Can you help me with either of these to see what kind of shape I'm going to get when I make my slice? Isaiah?
The
Second one, what kind of shape are we going to get?
a rectangle.
How do you know it's going to be a rectangle?
Because the side length is the. I just know it's gonna be a rectangle.
So we're going to get a rectangle, I agree. Make a note under here. Horizontal slices. Now that's perfectly horizontal, but horizontal slices will have the same shape as the base. Do you know anything about the dimensions of that rectangle that you get? We do know one thing, actually. Nope.
The 3.
Nope. Because to be 3 or 6, it would have to be on the bottom. Obviously, my rectangle's drawn bigger than it should be. If you wanted to be really accurate, you draw a rectangle that's about this big.
3 and 1.5.
This side, we know, has to be less than 3. Because it's not on the bottom, so since it's above the bottom, it's going to be smaller than 3. So, likewise, what do we know about that side? It's got to be less than 6. So my width will be less than 3, and my length will be less than 6. Because I know I'm not on the base. It got smaller when I raised above the base. Question?
No, I know the third.
You know the third one? All right, what do we get on the third one?
A triangle.
A triangle. Do we know anything about said triangle?
Yeah, we know that this base, or this line is 6.
This base that goes along here, parallel and the same as that edge, is 6.
Which means...
And if we knew the height of the prism, or sorry, the pyramid, if we knew the height of the triangle would be the height of the prism. This height of the triangle, sorry, I keep saying prism, I keep meaning pyramid. This height would be the same height as the pyramid. Because if I know the height of the pyramid from the base to the vertex, it's the same as the height of my triangle. If I know it. Questions, comments, or concerns on any of those? None? So try this on your own. You need to draw your shape and label everything we know about it. We're making a vertical slice through the vertex, and that matters very importantly, through the vertex. The direction that it's facing also matters. Remember, the side that we cut through, we do not use that length. The side we cut through, we do not use.
Can you help me?
Zach, I'm going to have you help everyone if you will. You passed earlier, so I'm coming back to you since I looked at your paper. What kind of shape do we get when we slice this? A triangle. What do you know about that triangle?
The base is 4 inches.
The base is 4 inches.
And the height is 6 inches.
And the height is 6 inches because it's the same height that the pyramid had. We see that because this meets the base at a right angle, that is the height from the base up to the vertex. It's the vertical height. It's not leaning or anything like that. Since it's the vertical height, that's the same height that the triangle will have. Any questions how we know that? Ethan, do you have something to say?
I just have something to add.
Okay, go ahead.
Since leaning in must be greater than 6.
Yeah, so if I drew a line, and I was about to get to this, if I drew a line down the front edge, down to the edge, notice where it connects. If I know that the vertical height is 6, this leaning edge will be more than 6, because look at this. If I know the distance from the top of the pyramid to the bottom of the pyramid, and then instead of dropping straight from the top to the bottom, I go from the top down to the edge, I have a further distance to go. I'm going to the same ground, but instead of taking a straight line, I take a diagonal line. We know that diagonal lines are always longer than a straight line. So the quickest way, or the shortest distance between 2 points is the straight line. We took a diagonal, it gets longer. So be careful. They will sometimes give you that length. They call it the edge length or the slant height. When they give us that, that's working for surface area. That we would not use for our slices. So just be careful when we look at things like that. So if we have a now up here, that was a square-based pyramid. So now we're shifting. Now we have a rectangular pyramid.
It looks like a square though still.
Okay. I mean, probably
I know.
this is the length and this is the width. Length is longer. Perspective, I know, perspective goofs with you though. Like how you see it based off the angle it's turned. We want to get an isosceles trapezoid section. Underline or highlight trapezoid. I want you to draw on your paper because there's multiple correct ways. I want you to draw on your paper how you think we could get an isosceles trapezoid. Remember, isosceles means that its two sides are the same. So an example of an isosceles trapezoid is that where those two sides are the same. So the top is going to be shorter, the bottom is going to be longer. The two sides have to be the same. So how would we do this? How would we slice this? If you're stuck, you can kind of come look at this if you need. How could I kind of chop into this to get an isosceles trapezoid? Chat with your neighbor and see if they did it the same way as you. You know, I'll have this as the top, this distance between here as the bottom, and these as my sides. well, if I'm at the exact same point here, the exact same point but there's other options too. We're gonna do this class. Oh, you have a different answer? Are you going diagonal?
No kidding.
Show me. Are you saying you're down?
I have a lot of other things. I wish we had Spanish. See, you don't. I don't say ananas. I say I don't say that because I can't even talk.
I think we're on the right track, but you're thinking three-dimensional, we want two-dimensional. Alright, bring it back together.
This is how I say.
Bring it back together. Who thinks they know? Cassidy? Yeah, your name came up and you weren't even in here, so. Actually, hold up. I'm gonna shift this so that it's above the glitch,
I used to live in a.
because the glitch line's kind of right across the middle.
Well, I lived in grandparents' farm.
Okay. So your line does not have any perspective to it.
I draw perspective.
When you hit the edge, you gotta change angle.
Call you up and you're going up there.
So I'm not gonna call either of you. If you're both gonna argue about who gets to come up,
I
neither
didn't
of you
argue.
get to.
You just started walking.
Yeah, but if we go, so if we went there and there, are you talking about also going back there and back here? So that's gonna get us a rectangle though. That's the only problem is if we make a horizontal cut, that's gonna get me a rectangle. Katie, what were you telling me when I was back there? So actually, so what Katie was telling me when I went back there, she was making a three-dimensional trapezoid. So she cut off the top of her pyramid, and if we got rid of the top, then what we would have left would be a three-dimensional trapezoid. It's like a section of a pyramid, but we don't want, like, a trapezoid is a description of a two-dimensional shape. So what we're actually talking about doing here, guys, is if I make a cut right here, and then come down this edge, and then cut across the bottom, and went down this back edge, that gets me an isosceles trapezoid. But here's the really cool thing. I do not have to cut vertically.
What?
I do not have to cut vertically. What I mean by that is, what if I want to cut through this edge as my long edge, but I want to come up to, I'm going to change my angle a little bit actually. I'm going to do this edge, come up to here.
Bless you.
So here, check it out on my triangle. I mean, cut through here, come down to here. So start at my right hand, end at my left hand. We're gonna cut diagonally through the trapezoid or through the pyramid. That's gonna get me a shape that is small up there, goes down the edges, and then this base edge. Let's say if this over here was like 4, that would then be 4. Whatever this length right here is, let's call that S. That would be S. And then these would have to be the same, even if they don't necessarily look the same. We've got a bunch of options here. Really, the only thing that you care about is cut straight with the edges. The base edges, you got to be straight with that. I can't cut like cockeyed. And then go straight down to another edge. So as long as my edges are parallel to the edges that exist, I'm okay. Yeah.
I really don't understand this.
What? I gotta know more.
Like, trapezoid. That's the cut. Why is that our shape if that's the cut?
Because the shapes that we're looking at are the shape of the cut. We're not looking at the three-dimensional. Hey guys, how rude is it when your classmate's asking a question and you're just talking to somebody else? And also, what she's asking probably might be something that you're wondering. I know some people just walked by. It doesn't matter. What we're talking about is what two-dimensional shapes do we get from the cut? So essentially, I'd be looking at the bottom of the top section and the top of the bottom section. What shape did I cut through? Like what was made? So let's imagine this cylinder and I cut straight through the middle. What shape would I get when I cut straight through the middle? Well, it's a circle, right? Because it's a circle on the bottom, a circle on the top. If I have a triangular prism and I cut through it horizontally like this, what shape do I get? Well, a triangle, because it's the same as the top and bottom. But if I flip it like this, and now I cut horizontally, now I'm going to get a rectangle that's smaller than the base. If I cut vertically, I'm still going to get a rectangle, no matter where I cut vertically. If I turn my vertical cut, now I'll get a triangle. If I come over to even weirder shapes, let's say a hexagonal pyramid. If I cut horizontally into it, I will get a smaller hexagon as the two-dimensional shape at my cut. I'm not worrying about what 3D shapes are left over. I'm worrying about what is the shape at my cut. Does that help make sense?
Yeah, I was really confused in why we were saying that.
Yeah, it's what is the shape at the cut.
Okay.
So if we cut it right here, down to here, across to the back, if I make that actually look right, and then right there, notice that even just when I draw my cut, it's a trapezoid. It looks weird when it's drawn in perspective, but it's a trapezoid. My cut would be a trapezoid. So let's look at these criteria. Plane is vertical, intersects the front face and the vertex. Remember, the front face, when you look at it, is the face like facing you, closest to you. So we have to look in. This face right here is my front face. So it's vertical, intersects the front face and the vertex. So I'm going to drop a point on my front face. I'm going to drop a point on my vertex because I have to intersect there. I know it's a vertical cut, so I can bring it vertically down, across to the back, and down the back. And we can draw these solid if you want, just because it's hard to do the dotted lines. Just remember that if we can't see it, we would normally do it dotted. Bless you. Bless you. So we would get a, what kind of shape there? A triangle.
A right triangle, wouldn't it? No, it looks weird.
It would be isosceles. Yeah. When we are working with right, do I need to separate you two? Like, honestly, do I need to separate you two?
No.
Can you handle sitting near each other? I'm not even talking to you, Oriana. I'm talking to Eli and Ethan, because Eli's back there doing some nonsense with one glove on. It's not funny. Like, you'd get kicked out of class for this or given detention if you're creating a distraction at other schools. We are very lenient here. So I ask you, in your brain, can you sit next to him?
No.
So make that choice. No, don't do it right now. Tomorrow when you come to my class, you make the choice to not sit next to him. I want to see you making the mature decision. And I'm not here tomorrow, so I'm specifically going to leave my notes to ask how you behaved. Okay? A few of you guys, this class isn't bad, but a few of you guys in reading or AO and other classes need to make those mature choices and decide who can I sit beside and who shouldn't I sit beside. All because they're your friend doesn't mean you should sit by them. I've got some really good friends that like work here in Worthington, but when we go to like Worthington meetings, if I sit next to them, all I want to do is talk to them. We like make little side comments. When Mr. Estes and Mr. Cabilo sit next to each other in staff meetings, it's not good because they talk to each other like the whole time. They get in trouble. So they don't most of the time because they know they can't. Make the mature decision. Put your place in, or put yourself in the place of most potential. Not the place of most fun, but the place of most potential. Where can I learn? What about a horizontal plane halfway up the pyramid? So try your best to put points halfway up the pyramid. So probably about there and there maybe. Make sure that you draw this in perspective. This front line should not be flat. It should be parallel to the base of the pyramid. So it should have a little bit of an angle to it. Then your side should have an angle as well. Your back should be dotted if you can draw it. And your left side should be dotted if you can draw it. Mine doesn't look very good. I'm going to try again. Sometimes you realize, hey, that didn't turn out great. That's better, but I had to make it all solid. It's really hard to draw dotted because it's hard to keep in a straight line. So again, we would get, what's it called when it's the same shape but not the same size? I want you to draw an arrow to your rectangle that you drew halfway up the pyramid and the rectangle at the base. These shapes are what we call similar. We're going to do more with similar shapes here in this next chapter. Similar shapes are the same shape but a different size. So maybe you have two equilateral triangles. One is 1 by 1 by 1. Bless you. The other is 3 by 3 by 3. Those are similar shapes. Same, they're both equilateral triangles, but they're not the same size. Try this on your own. Two triangular cross sections, bless you, each formed by a plane that intersects the vertex and is perpendicular to the base. You've actually got many options here. You've got many, many options here. Two triangular cross sections formed by a plane that intersects the vertex and is perpendicular to the base. Bless you. Are we allergic to math today, guys?
Yes. No.
Like every 5 seconds, someone new is sneezing.
I'm never allergic.
Reading Max sneezed like 15 times.
Yeah, because you know the whole pie is all.
Oh, no, it's good. He doesn't.
Not all.
I love math. Like I sneeze because my nose is running. But
Everybody's getting that cold.
my mom sneezes a lot, so I sneeze a lot. So it's a genetics thing. Hey, what about you? Your dad
Bless you.
Bless you.
Yeah, that's right.
Do I have to make my triangle parallel to the front or the edge, like the right or left, or does it matter? Like to have triangular cross sections. Ethan, you've been fighting to.
A good one. You could go diagonal, so you could make a diagonal slice, right?
How so? Give me more details.
Can I just
Sure, you can come draw it.
Oh, I see it. The base is
So what I'm saying, while Ethan draws, if you look up here, I could go straight like this to be parallel with the right and the left edges. I could go straight like this to be parallel to the front and the back edges. But what if I turn? If I'm not parallel to these edges, do I still get a triangle?
That's a trapezoid.
Ooh, that would not give me a triangle. It has to intersect the vertex.
Then my other one is just the straight down cut.
So that one does work, but that is parallel. So what I'm asking is, do we have to be parallel?
No.
Tom? Not parallel? You're
Yeah,
saying?
not
Okay.
parallel.
Come up if you want.
Okay.
Try the other got it. If you're ready for it. I love it.
Yeah.
Boom. That's exactly what I was trying to get us to get to. The biggest triangle that you could form by slicing through your pyramid, if you didn't see it drawn, when Thomas drew it, I'll draw it again, standing off to the side. Thomas started down here and came up to his vertex, but then he came over to this vertex, and then my line goes diagonally across the base. That's the biggest triangle that we could make, is cutting straight diagonally through it. Now, depending on whether this was square or rectangle would depend on what type of triangle we would end up with, whether it's isosceles or whether it's scalene. But either way, it is a triangle. Real quick, explain how to slice a rectangular pyramid through the vertex to get triangles of many different heights. Eli?
You still have it go to the vertex, but you just spread it across different points in the base.
Yeah, so move it. So one would be coming straight to the middle, but what if then I do another one coming out further? And if I do another one over here, these are all going to have different heights. It's a little hard to see because the colors layer on top of each other. But imagine cutting straight through the vertex and then angling. If I angle it, it gets bigger because the height gets bigger. That's all we got time for today. I will not be here tomorrow, so you will wrap up the chapter with the guest teacher. Me? I have a meeting at the WEC. Well, I'm taking a class right now, is why I've got more meetings this quarter than normal.